Half a day, students. Today's lesson we're going to be going over factoring. So we're actually going to keep it simple today. We're going to work on prime factorization and looking at greatest common factor. We'll get into factoring trinomials in the next video. So here we go. First of all, it's important to know the difference between prime and composite numbers. Prime numbers are divisible only by themselves and 1. Composite numbers, on the other hand, they're divisible by other numbers as well. So they have different factors. And just a side note there, 1 is neither prime nor composite. So we actually want to get comfortable with knowing what the different prime numbers are. Again, these are numbers with no other factors but itself and 1. So we have the numbers listed here. You can note that 2 is the only even number that is prime because every other even number is divisible by 2. And if ever it's asked, if ever you need to prove that a number is composite, all you would do is just show its factors. So if I want to see that, okay, I know 27 is composite because it's equal to 9 times 3. So composite numbers can be written as a product of numbers other than itself, right? So we have different factors. In the next slide, we're going to be going into finding the prime factorization of numbers. And this basically is just us breaking it down to just prime numbers because every number is just a product of primes, right? So 27 is just 9 times 3. Okay, 9 is not prime, but 9 is 3 times 3. So 27 is just 3 times 3 times 3. So we're going to be going into stuff like that. Determine the prime factorization of 36. So we're breaking it down into just prime numbers, right? So what I like to do is do a tree. So I'll start with 36. And I'll say, okay, I know 36 is 6 times 6. And whichever factors you think of, it'll always break down to the same one. So it doesn't matter if you were to choose 3 times 12, 6 times 6, or 4 times 9, they'll all turn out to the same thing. So I don't have any prime numbers yet, so I'll break them both down again. 6 is, I know, 2 times 3. And once I get a prime number, I actually just circle it because I know that's the end. Okay, and this is, again, 2 times 3. And the prime factorization, what I'm going to do is I'm just going to list them, and I'm going to count how many of each I have. So I want to start from the smallest one, so 2. I have 1, 2, 2. So that's actually going to be 2 times 2 times 3 times 3. And I know 2 times 2 is just 2 squared times 3 squared. So that's really the prime factorization. Just break it down to a product of prime numbers. 63, I'll do the same thing. Okay, I know that's 9 times 7. 7's already prime, so I'm done. 9 is 3 times 3. So I have 3 squared times 7. Pretty simple. 75. Whenever I see numbers like 75, 50, 150, 125, things like this, I always break it down into 25s because I always think of just quarters, right? So we think, how many quarters go into 75 cents? 3 quarters. 3 is already prime. 25 I know is 5 times 5, which are both prime numbers. So I have my prime factorization of 75 is just 3 times 5 squared. 1350, this one's a lot larger. When I'm breaking it down, I might just divide it by 10 because it has a 0. Or I might divide it by 2 because it's even, right? Or by 5 because it ends in 0. For this one, I might just divide it by 10. So 10 times 135. Okay, I know 10 is just going to be 5 and 2, so I'm done there. 135. I'm still not sure. I'll divide it by 5. I know it's divisible by 5 because it ends in 5. 135 divided by 5. 2, 10, 35, 27. 5 is prime. Circle it. 27 comes out to 9 times 3. 3 is prime. 9 is just 3 times 3. So now I have all prime numbers at the end. So I have 2, and I have 3 3s, 3 cubed, 5 squared. So even though I have a large number, it's actually fairly simple to break it down. If you had divided by 2 at first, that might have been easy also. So just keep breaking it down until you have only prime numbers. Now we're going to be looking into greatest common factor. So the greatest common factor is a number that divides all terms. So what I want to do is find the prime factorization of each of them and then see what they have in common. So when I find the GCF of 24, I might do it on the side or I might think of it in my head, but I like to just draw the tree just because it's easier. 24 I know is 2 times 12 to its prime. 12 is 3 times 4. And then 4 is 2 times 2. So I have 2 raised to the 3rd power. Or I may actually just write it out. Let me see. 2 times 2 times 2 times 3. 1, 2, 3, 4. That's for 24. For 60, that's 6 times 10. 6 is 3 times 2, both prime. 10 is 2 times 5, both prime. So we have 2 times 2 times 3 times 5. When I want to find the GCF, so these are fairly easy numbers, so you might actually already think, okay, 24 and 60, those are both divisible by 12. Maybe you know it in your head already. But when it's bigger numbers, this prime factorization will make it a lot easier. So what I want to do basically is find out what do they have in common. So I know they both have at least 2 different 2s. They both have 1 3, right? So the GCF is going to be the product of these numbers. So it's going to be, the GCF is 2 times 2 times 3, which is 12. So 12 can divide both 24 and 60. Or I mean to say that 24 divided by 12 and 60 divided by 12 are going to give you all integers. Moving on to the letter B, find the GCF of 6x cubed and 15x squared. So now we have variables involved, but it doesn't change too much. Now we just have another, think of it as like another prime, right? So we have 6x cubed. That's just going to be, okay, 6 is an easy one. I know that's just 2 times 3, right? So we have 2 times 3 times 3x's. 15x squared. That's another easy one. So that's 3 times 5 times 2x's. Find again what they have in common. They both have at least 1 3 and 2x's. So their GCF is going to be equal to 3x squared. Okay, so even though you're not going to have questions that explicitly ask you in the test, what is the GCF of this and this, it's important to know because this is actually the first step that you want to do when you are factoring. You want to see if the terms have a greatest common factor, right, other than 1. You want to see if there's something that you can take out so that it makes the factoring itself easier. Okay, so looking at another example, now we have 3, so I want to see what all 3 have in common. So I'll just write these down. Okay, so you have 5x cubed, y squared. This one's easy, 5's already prime, so we have 3 x's, 2 y's. 10x squared, y cubed is 2 times 5, right? Then we have 2 x's, 3 y's. The last one, 25x, y to the 4th. 5 times 5 is 25. Then we have x and 4 y's. From now, I'm going to find out what they have in common. They all have at least 1 5, at least 1 x, and 2 y's. There's nothing else that can go into all 3. So my GCF is going to be 5x, y squared. So it's simple as that, prime factorization, and then find out what they have in common. Now we're going to go into actually applying this when factoring. So if we have something like 6y minus 9, this is very simple. All I want to do is find what is the GCF of 6y and 9. I know that both of these numbers are divisible by 3, right? So I might actually just say, okay, this is equal to 3 times 6y divided by 3. That's just going to be 2y. Negative 9 divided by 3 becomes negative 3. I like to call this undistributing. So it's not a real word in math. Don't use it in front of your other teachers. But I like to call it undistributed. It's called factoring or factoring. But a lot of times it's easier because, okay, I can see I'm just doing the opposite of distribution, right? I'm taking something out from each of them. So if you're not sure of your answer, all you can do is just distribute, right? So if I was to distribute this, that'll give me 6y minus 9 because I'm multiplying. So we're doing the opposite. Looking at letter B, 6x cubed plus 15x squared. I know the greatest common factor, okay, 6 and 15. They're both divisible by 3. They also are both divisible by x squared. They both have at least 2 x's, right? So you could do the whole thing that we did in the last page, which was to write out all the factors and then find out what they have in common. But the more you do it, the easier it'll be for you to just know it in your brain, right? So 6 and 15, their GCF is 3. X cubed and x squared, their GCF is x squared because they both have at least 2 x's. From there, 6x cubed, 6 divided by 3 is going to be 2. X cubed divided by x squared, I have a single x left. 15 divided by 3 is going to be 5. And then x squared is already taken out, so I have no x's left, so that becomes that. And again, distribute and multiply to see if your answer is correct if you're not very sure. Looking at this one, 28x cubed minus 36x squared. So sometimes if you actually choose a number that's not exactly the greatest common factor, you can actually still take it out later. It's an extra step, but it's still workable. But for this one, okay, 28 and 36. Maybe I'll actually want to do prime factorization of those just because I'm not super sure. 28 I know is 7 times 4. So that's going to be 2 times 2, right? Okay, so we have 28x cubed is 28. We have 2 times 2 times 7 times 3 x's, right? And then we have negative 36x, so 36 I know is 6 times 6. Then we have 2 times 3 and 2 times 3. Okay, so I have 36. X squared is going to be 2 times 2 times 3 times 3 times 2 x's. Find out what they have in common. They both have at least 2 2's and 2 x's. So my GCF is going to be 4x squared, right? So that's what I'm going to factor out, 4x squared. 28 divided by 4 is 7. And there's a leftover x there. Minus 36 divided by 4 is 9. And I don't have any more x's. So this is the factorization of 28x cubed minus 36x squared. Again, distribute and check if your answer is correct if you're not sure. Moving on to the last problem here, we have 3 terms. So I want to find out the GCF of all 3 of these terms. So I'm just going to rewrite it just so I can see it a little bit better. When you're rewriting, be very careful because if you write it wrong, of course, that's going to mess you up, right? So, okay, let me do this on the side. Okay, 18 I know is 3 times 6. 6 is 2 times 3. So I have 18x cubed y to the 4th is going to be 2 times 3 times 3 times 3 x's, and then I have 4 y's. Then we have 12 x squared y cubed. 12 is a little bit easier. 12 is just 3 times 4, right? So 2 times 2 times 3. Then we have 2 x's, 3 y's. 48 x to the 4th y cubed. 48, okay? 48 is just 4 times 12. That becomes 2 and 2. This is 3 and 4. That's 2 and 2 again. So we have 4 2's. A 3. 4 x's. And 3 y's. You'll notice later on when you're doing the variables, all you do is take the smallest number that's there, right? So, okay, we would have at least 1, 2, at least 1, 3. We have at least 2 x's in each of these, right? And at least 3 y's. So our GCF, we know, is going to be 2 times 3, 6, x squared, y to the 3rd power. And again, I said you can look over here, right? So if I was to look up here, the smallest exponent of x is x squared, right? The smallest exponent of y is y cubed. So that's how we get the x squared y cubed. And 6 is just, okay, all these numbers are divisible by 6. Factoring that out, I'm left with, okay, 18 divided by 6 is 3. X cubed, I have leftover x. Y to the 4th, I have leftover y. Minus 12 divided by 6 is 2. X squared, that's gone. Y cubed, that's gone. Then we have minus 48 divided by 6 is 9. Oh, sorry, I mean 8. And for x to the 4th, we have 2 leftover x's. And y cubed, no leftover y, so that's it. And you'll notice that these interior ones right here, they actually match up with what's left over in this bottom part where you did your prime factorization, right? 3xy, then I have 2, and then I have 2 times 2 times 2 is 8 x squared. So if you're not really sure, but you can do that at the bottom, but it might get confusing. But it's pretty interesting to note that it's just whatever's left over. Once you divide out your greatest common factor. So that's it for today's lesson. This is, again, the first part of factoring. In the next videos, we'll be going over factoring trinomials as well as polynomials with 4 terms. Okay, we're going to look into factoring by grouping and special cases. It's going to be really good, really fun. I love factoring. But if you already know how to factor and you're good at it, I suggest you actually don't watch the next videos, because factoring is one of those things. If you understand it a certain way, then you don't really get other people's way of factoring. So just something to think about, and I hope you have a good day. Okay, bye.